Hey everyone, and welcome to the last video from chapter 14, which I'm hoping that you're watching back to back with the chapter 14.2 video, because in this video, we're going to be expanding on our discussion of the money multiplier by adding in a little bit of realism. So we're going to revisit the money multiplier, and this time consider the banks and the non-bank public's role in the money and deposit multiplier. So let's go over an important fact. If you remember from the last hypothetical from the last video, we assumed that each time the person taking out a loan deposited all the currency that they received in the loan in a different bank account. We know that that's not actually how it works. A lot of times, individuals will hold on to a little bit of the cash. And the smaller the amount of currency that is deposited with another bank is, the less that they can loan out. So if I get a $100,000 loan, uh, and I deposit all $100,000, the bank can loan out $90,000. If I receive the $100,000 loan and I deposit out 50,000 or deposit only 50,000, the bank can only loan out 45,000, even though the initial loan was still the same. So obviously, we need to consider this fact when we derive a more accurate money multiplier. In fact, when we can, all things considered, our simple deposit multiplier needs to be refined in three ways. First, we need to somehow link the monetary base and money supply together. Second, we need to include the effects of the money supply process of changes in the desire to hold currency, like the hypothetical. Third, we need to include the effect of changes in banks' desire to hold excess reserves instead of just loaning everything out. So, let's revisit the very first thing that we talked about in chapter 14, which is the money supply formula, capital M. The money supply is equal to the monetary base times the money multiplier. And we can rearrange this formula to try and link everything back together. We can get that the money multiplier is equal to the total money supply divided by the monetary base. Seems like a fairly accurate ratio, right? And it is. This is the truest definition of the money multiplier. However, calculating that is quite tricky and is only uh, present looking instead of forward looking, to so it's completely useless for like policy and stuff. But we have a couple definitions to help broaden our understanding of this formula. First, if you remember, we defined the monetary base assuming that we are using M1 as currency plus checkable deposits. So C plus D is just the purest definition of M1 that we've been using for 5 chapters. We also defined the monetary base in the 14.1 video. The monetary base is currency held by the non-bank public plus all reserves, both reserved or required and excess. So in equation 2, we just have a slightly expanded definition that says the exact same thing as in equation 1. But we can do a little bit better than this. Let's define the currency to deposit ratio first. This is just the non-bank public's holdings of currency relative to their holdings of checkable deposits, D. And this is very useful and also easy to calculate because at any one time, the Fed will always know how much currency they have issued and how much currency is being held in bank reserves. So let's return to equation 2. Right here is the exact same equation that we had in equation 2. What we're going to do is multiply every single term by 1 over D. So 1 over total deposits. We're going to go in and we're going to do 1 over D times C, 1 over D times D, 1 over D times C, 1 over D times required reserves, and 1 over D times excess reserves. We can now do a tiny bit of simplification. We're going to get from right here D over 1, D over D. So that just becomes 1. And so we get a little bit of a nicer definition, but this looks kind of weird. Wait a second. We can see this term right here is the required reserves over the total deposits, which we know is the reserve ratio and is also externally set by the Fed. So let's substitute that in to get equation 4. Our money multiplier is going to be the currency to deposit ratio plus 1 over the currency to deposit ratio plus the required reserve ratio plus the excess reserve ratio. And so we can get a good definition of money supply in the US economy. It's equal to what we derived in equation 4 times the monetary base externally set by the Fed. So how does this work? We're going to use a nice simple example that builds off of the example from the last video. Let's once again assume that the Fed purchases $100,000 in T-bills from Wells Fargo. Currently, let's also assume that there's $500 billion in currency held by non-banks and $1 trillion in deposits. We therefore get a required reserve rate. We also have a reserve ratio of 0.1 and excess reserves of $150 billion. So that means that we need to calculate a couple things. We need to calculate the currency to deposits ratio and the excess reserves to deposits ratio. Uh, we get the currency to deposits ratio of 0.5 and the excess reserves to deposit ratio of 0.15. Now, everything else is the exact same as in what we derived in chapter 14.2. We still have $100,000 in T-bills and a required reserves of 0.1. The only difference is that we now stipulated what is being held by non-banks and in bank reserves. But by just adding these facts in, we get a radically different number for the money multiplier. Instead of 10 like we calculated last time, we can just plug and chug everything according to the color to get a money multiplier of 2. So we derive a money multiplier of 2 dramatically less, which means that the money supply from the $100,000 T-bill purchase from Wells Fargo only increases the money supply by $200,000, so way less than $1,000,000. Now, note a couple stylistic facts. Let's do a couple simple comparative statics. The money supply will always increase if either the monetary base or the money multiplier increase in value, which stylistically makes sense, right? Additionally, an increase in the currency to deposit ratio causes the value of the money multiplier to decline. So if we come back up here, that means that if the non-bank public increases the amount of currency they want to hold relative to their deposits, this number is going to get bigger. Now, within reason, that means that this term is going to get smaller. And so that makes sense, right? Because if I don't deposit, if I deposit the entire $100,000 that I get as a loan from Wells Fargo can then loan out $90,000. However, if I only deposit $50,000, then only 45,000 can get loaned out, which means that this multiplier effect approaches zero much more rapidly. So stylistically, this makes sense. Uh, and this is also why bank runs are extremely dangerous to monetary policy. When we look at this new formula, if people don't trust the bank, then that means they're going to hold a ton of currency rather than depositing it, meaning no matter what the Treasury does or what the Fed does, any open market operation is going to have a limited effect since people will not deposit any loan they take out with a different bank. Now, another note is that an increase in the reserve ratio causes the money multiplier to decline, which once again stylistically makes sense. And then finally, an increase in the excess reserves to deposit ratio will cause the money multiplier to decline. Once again, stylistically, this should conceptually make sense to us, just anecdotally thinking about this hypothetical we brought up in the last chapter. Now, we can even add to this formula a little bit even more because we already identified that the monetary base is actually comprised of the non-borrowed monetary base, so B non, and borrowed reserves, which operate quite differently. Therefore, if we so desire, we can expand our money supply formula to get equation 8, which gives a much more complete and accurate description of the money supply process. And it can handle additionally current market conditions very well because remember, there are no required reserves right now in the United States. And we can still handle it here instead of letting our money multiplier blow up to infinity. Now, finally, let's look at these tracked uh, economic tools for the Fed. When we look at the monetary base, we can see that it generally since 2009 has been going up. And it usually tracks the M1 supply pretty well. Uh, Additionally, the money multiplier is usually actually since 2009 about 1, which is a departure from what it was beforehand, where it was at about 2. And then we also calculated a couple ratios. The currency to deposit ratio, it has declined a bit since 2009. And there may be a few reasons for this. First, that people may not be holding on to currency, they're just investing it into non-checking accounts. So they may be putting it into the stock market or etc. That may cause the currency to deposit ratio to decline. They may just not trust banks as much anymore, especially given the rise of like Venmo, where you can now keep your uh, cash in Venmo. On the flip side, the excess reserves to deposit ratio skyrocketed from the financial recession, and ever since then has been having problems coming back down to near zero where it was all the way leading up to the 2007 financial crisis. And stylistically, this also makes sense that anytime there is a recession or a financial crisis, that banks are going to hold on to excess reserves rather than get over levered in a time of recession. So you can see that in both recessions in this graph, massive surges in the excess reserves that bank had. Now note that in 2009 or in 2007, when it was a bank fueled financial crisis, the excess reserves held went up way more than in 2020 when the Fed did a lot to encourage banks to lend as much as they possibly could. But with that, you are now done with chapter 14. Go ahead and take the chapter 14 quiz, and you only have one chapter left in the class.